Welcome to my channel, The Science Academy. I am Narayan Chandra Muzumdar, lecturer, Department of Physics, Rajukutura Model College, Uttara, Dhaka 1230. Stay safe, stay home. Class, today I'll discuss uh, on subject physics of class 10, chapter 13, modern physics and electronics. What will uh, learn from this chapter? Explain radioactivity, explain radioactivity, explain the characteristics of alpha, beta, and gamma rays, describe the sequential development of electronics, differentiate between analog and digital signals, explain semiconductors and integrated circuits, explain the function of microphones and speakers, explain the principles of the function of selected communication technology, devices, explain the communication process with the help of internet and email, investigate how information and communication technology devices influence our life, be conscious about how to make proper and effective use of information and communication technology devices, and raise consciousness among others. Today's learning outcomes. You will be able to explain radioactivity, you will be able to differentiate among the alpha, beta, and gamma rays. So what is called radioactivity? The emission of ionizing radiation or particles caused by the spontaneous disintegration of atomic nuclei, radioactive substance, or the radiation emitted by these is called radioactivity. With the increase of number of protons, to keep this nucleus stable, the number of neutrons also increases. But when the proton number exceeds 82, the nucleus starts to become unstable. This unstable nucleus try to become stable by emitting a kind of radiation. We call this process radioactivity. The radiation that comes out from the nucleus is called radioactivity also. So what is that means? Think that this is atom, nucleus of the atom. And if number of proton, this is the proton, and there is neutron. So if this number of proton exceeds more than 82, then the positive charge, and also this proton also positive charge, this positive charge repel another positive charge, they will produce huge repulsion force. That's why this atom, this nucleus will be unstable. To become stable this nucleus emit some rays, and after emitting these rays, it will be stable. This process is called radioactivity, by which some rays emitted from the atom. Why does radioactivity occur? A proton is positively charged, so the nucleus cannot be formed only with protons, because the protons will be thrown off due to the strong repulsion force. So there is chargeless neutrons with protons in the nucleus, and nuclei become stable due to very strong nuclear force between protons and neutrons. Though there is only one proton at the center of a hydrogen atom, There are also hydrogen nuclei with one or two neutrons. With the increase of the number of protons, to keep this nucleus stable, the number of neutrons also increases. But when the proton number exceeds 82, the nucleus starts to become unstable. This unstable nuclei try to become unstable by emitting a kind of radiation. We call this process radioactivity. The radiation that comes out from the nucleus is called radioactivity. When and who discovered radioactivity? In 1896, Henry Becquerel discovered the existence of radioactive rays from uranium for the first time. Later on, Ernest Rutherford, Pierre Curie, Marie Curie, and other scientists discovered radioactivity of other elements. Since radioactivity it is not influenced by external pressure, heat, electric or magnetic field, and cannot be controlled, it is accepted as a nuclear phenomena. Due to radioactivity, radioactive rays emerge and this changes the structure of the nucleus and turn into a different element. This is also called this is also observed. The main three radioactive rays that emit from the nucleus are alpha, beta, and gamma rays. One thing I want to mention here, that is radioactivity is completely nuclear phenomena. What is the nuclear phenomena? They think that there is atom. It is saying that it is uranium 92. That means there is 92 proton, 92 proton. Think that. But if you want to be disintegrate this atom into another atoms, if you want to make this atom radioactive, then if you want to apply force here, you want to apply pressure here, if you increase the temperature, if you increase the electric field, magnetic field, it will this atom will not be influenced. So the rays emitted from the atom, that is completely out of the influence of magnetic field, heat, pressure, etc. That is completely nuclear phenomena and it is spontaneous. Are the atoms having atomic number more than 82 radioactive? It means it is not fact that the when proton number exceeds 82, only then the nucleus become radioactive. Any nucleus of other atoms may be radioactive too. We have classified atoms on the basis of their electron number, which is equal to the number of protons. External properties, nature, chemical properties, every feature of an element depends on the classification of electrons. So the number of neutrons of an atom can be different even if the number of electrons and protons is equal. These types of elements with different number of neutrons are called isotopes of that element. So an isotope of an element may be stable, but another isotope of that element may be unstable or radioactive. For example, we can say that the element carbon, in which nucleus are six protons and its three isotopes are also. Carbon 12, there is six protons and six neutrons. Carbon 13, six protons and seven neutrons. Carbon 14, six protons and eight neutrons. These three are isotope to each other, but they are among these three isotopes, carbon 14 is unstable or radioactive. So uh, only the atomic number more than 82, they are radioactive. It is not correct. Less than 82, atomic number less than 82 may be also radioactive and they are isotopes. There is carbon 14, it is radioactive isotopes because its neutron number is 8, but This one is 6 and this one is 7 and 6. So they are isotopes to each other, but these isotopes are unstable and it is also radioactive. Which rays are emitted from a radiation? Alpha rays, beta rays, and gamma rays. Alpha rays. Alpha ray or alpha particle is actually helium nucleus. So a helium nucleus contains two protons and two neutrons. So it is a charged particle. So its path of motion can be influenced by electric and magnetic field. When an alpha particle emits from a nucleus, it possesses some m million electron volt of energy. So when it passes through air and collides with the molecules, atoms, it can ionize them intensively. In air, the path of motion of alpha particle is straight. Since an alpha particle is a helium nucleus, it cannot travel far through air. It loses its energy by ionizing air molecules. Atoms uh, travels approximately 6 centimeters through air before stopping. An alpha particle can be stopped by using a sheet of paper. It creates photophosphorescences on zinc sulfide screen. An alpha particle creates many free electrons by ionizing molecules atoms of air in its path of motion. Its presence can be detected or its energy can be measured easily by collecting these free electrons. When an alpha particle comes out from a larger radioactive nucleus, then this nucleus atomic number will be reduced by 2 and its nuclear number will be reduced by 4 because an alpha particle consists of two protons and two neutrons. For example, the isotope of uranium turns into thorium by emitting an alpha particle. Uranium 238, thorium 234 plus helium nucleus. The atomic number of uranium is 92 and thorium is 90. It's notable that the number of electrons of an atom is not significant. Radioactive nuclei of atoms can be easily give up or receive extra electrons to and from its surroundings. Okay, the things I want to mention here, that is uh, alpha particle. It is nothing but the helium nucleus. You know, the helium nucleus, there is two protons, and two neutron, and also two electron. This is the two electron. If these two electron released from the atom, this will be helium nucleus. That is helium 2, 4, and there is the nucleus 2 plus, but that means lack of two electron. This is called alpha ray. And when this alpha ray emitted from an atom, the nuclear number will be reduced by 2. Think that, for example, nucleus 230, for example, for uranium, here is 238, but that's why its nuclear number will be reduced by 4, 234. And this 234 plus the 4, that will be 238. And the nucleon number will be atomic number will be reduced by 2. This is the 92 atomic number, and the atomic number of thorium is 90, and the atomic number of helium, that is the 2, and 90 plus 2, that is 92. So there is no destruction of uh, fundamental particles, electron, proton, or neutron. Here also the paper, aluminium, alpha ray just can penetrate this paper, aluminium, this this paper, and the beta ray can penetrate this aluminium sheet. This is the aluminium sheet, 3 or 5 millimeter, And gamma ray can penetrate also lead, this lead 3 to 5 centimeter. Now, what is beta ray? A beta particle is actually an electron. It is not a course, a matter of wonder that a nucleus is consists of neutrons and protons only. So, how does an electron come out from a nucleus? For this, inside the nucleus, a neutron has to dissociate into a proton and an electron. For example, neutrons converted to proton, proton, and electron. Neutron has to dissociate it into proton and electron. That is, a chargeless neutron is converted into a positively charged proton and a negatively charged electron. So the total amount of charge remains unchanged. In the right side of the equation, this symbol indicates the antiparticle of neutrino, antineutrino, the mysterious particle of the world of physics, which is chargeless and its mass is very small. So here, the charge of neutron is zero, and the charge of positive and negative it is also zero, and it's the charge of antineutrino that is also chargeless. When an alpha particle is emitted from a nucleus, it comes out uh, with a definite amount of energy. But in the case of a beta particle, it is not true. The energy of the beta particle depends on the part of the total energy radiation received by the antineutrino. Since a beta particle is negatively charged electron, it can be influenced by the electric and magnetic field. When it passes through matter, it can ionize the molecule as atoms of the matter due to the collision with them. Then the size of a beta particle is much smaller than that of alpha particle. Its penetrating capability is more than the alpha particle, and it can penetrate deeper into matter. It is possible to stop a normal beta particle by a few millimeter thick aluminum sheet. When radiation of beta particles occurs, a proton is increased in the nucleus by deducting of a neutron. So the number of nucleons remain the same as the atomic number depends on the number of protons. The atomic number of the nucleus increases, and a different nucleus of a different element is formed. For example, radioactive carbon isotope is converted to nitrogen 14 due to beta radiation. That is carbon 14 to carbon, nitrogen 14, and that is electron, that is this is the beta particle and antineutrino. An interesting matter is that not only the emission of electron is beta radiation from inside the nucleus, the emission of antiparticle of electron positron is also called beta radiation. For this reason, a proton has to be converted into neutron inside the nucleus. That is the equation: proton converted to neutron and positron plus neutrino. This reaction cannot take place outside the nucleus. This is because the mass of the neutron is more than that of a proton. In this process, the number of protons decrease by one, and hence the atomic number also decreases by one, and a nucleus of a different element is formed. Though neutrinos or antineutrinos are emitted during beta radiation, they are not considered to be radioactive rays. This is because they are chargeless and they are so inert then that even a few light years thick lead sheet cannot stop a neutrino particle. A gamma ray is actually an energetic electromagnetic wave. It has no charge, but it has but as it is strong, its wavelength is very low. Regardless of energy of the gamma ray, its velocity is equal to that of light. When nucleus becomes excited by radioactive radiation alpha or beta particle, then extra energy comes out. as gamma ray and the nucleus be excited. The gamma ray is chargeless and massless, so the atomic number of a nucleus does not change due to the radiation. Since gamma ray does not have any charge, so it cannot be influenced by an electric or magnetic field. And because it is chargeless, it cannot directly ionize atoms or molecules, but the electrons can ionize atoms or molecules in different processes, and from that we can understand the presence of gamma ray to stop. Gamma rays with energy equal to that of alpha and beta particles, a thick layer of lead of several centimeters is needed. So evaluation, I want to evaluate you. What are the characteristics of alpha ray and what are the characteristics of beta ray? Your homework will be what are the difference among the alpha ray, beta ray, and gamma ray. So thank you all. Thank you so much.